Hello once again, my name is Emmanuel Senjumva and I'm the one who is going to be with you in this session of cable sizing. So before we continue here, there are some conditions that you can check before calculating the cable size. The first one is to check whether your cable is able to carry the maximum design current and also its normal transient peak. The second one is that cable you have chosen must not generate the voltage drop that is above the allowed values. Here are four things that you can check before calculating the cable size. The first one is the installation method. Here they are underground conductors. There are those conductors that are installed in the ceilings. There are others which are in cable trays or those without cable trays. There are those one which are installed on the walls or inside the walls. There are different methods that you can use in your installation. The second one is the ambient temperature that you are working on. The third one is the grouping cables. This grouping includes single core cables and also multi-core cables, and also you have to check the voltage drop. So here are the steps while determining the cable size you can use. The first one, you have to calculate the design current and the circuit breaker current rating. Hope you have gained the knowledge for calculating the design current in the session that precedes this one. So the second one is the choosing of protection device. Then after getting this protection device, you can determine the collection factor. So this collection factor you can check depending on the installation method and also the temperature you have. Then after finding this one, you shall be calculating the maximum current capacity of the wiring system. This one will be giving you the size of the conductor. But if you get this size of the conductor, please check the voltage drops that can be allowed by your conductor, and you have to make sure that this voltage drop is below the allowed value of the voltage drop. So here is the formula that you can use while calculating the voltage drop. You can use voltage drop, which is equal to B. This constant B stands for 1 for 3-phase and also 2 for single phase. Then multiply with phi 1. This is the resistivity, which is equal to 0.0225 for copper and also 0.036 for aluminium, times length of the conductor over cross-sectional area of the conductor, then multiply with cosine phi, which sometimes equal to 0.8, then plus this coefficient, which is equal to 0.8 times this one times 10 power negative 3 ohm per meter. For multi-core cables, if you have single core cable, you can use this one, and if you have single core cable which has spacings like this one, D equal to 8 R, this D is the distance between conductor, then this R stands for the radius of the conductor. Then you can use this value. So you can multiply with sine phi, then multiply with design current. So if you get the voltage drop, for example, you have single phase system, you get the voltage drop of 10, you have to divide this 10 with that 220 as the nominal voltage times 100 to check the percentage voltage drop. Then if you see your voltage drop is greater than 3, which is maximum allowable voltage drop, you have to go back into your formula, then use the cross-sectional area which is greater than the one you have used before. So you have to make sure you get the voltage drop which is less than 3%. So here I have the table that you can use while calculating the cable size. These are cable size, these are their current carrying capacity. So these are letters that correspond to the method you have used while installing your cable ring. We have B, we have D, we have C, we have E, we have F, and here we have D, which stands for the underground cable ring. So for this cable, for example, you have letter C, then you have single phase. These 3 stands for 3 phase, these 2 stands for single phase, phase and neutral. These are 3 phases. So this is the range for PVC, and this is the range for XLP, but most of the time we use PVC as it is the insulation which is not which is not expensive compared to this XLP. For example, you have calculated your current, then you get in single phase 51. If you have got 51, you have to consider this 57 as it is greater than that 51 you have found. Don't use this 41, as this 41 is not capable of carrying that 51 current. Then use this one which has 10 millimeter squared. It is the same for this one for letter D, and these are copper. So here I have aluminum cables, and they are the same in calculating the cable size. Here I have letter D for aluminum, and they are the same while calculating their cable sizes. So here I have some examples with simple calculations. For example, this one it is saying that if we have lightings and smoke alarms which has MCB of 6, you can use 1 square millimeter. And for example, this Radiant kitchen, if it has MCB of 32, you can use 4. These are the examples of different installation that you can use different cables depending on the MCB you have. So let me go to the cable sizing of the ground conductors. So while cabling the conductors for ground, you have to consider your cable that you have found before. If you have found the conductor which is less than 16 square millimeter, you can use the same wire. For example, if you have found 6 square millimeter, you can also use 6. If you have 16 up to 35, you can use 16. Then if you have greater than 35, you can use a half of that conductor. So my conclusion goes to how to calculate the cable size, and also make sure you calculate the circuit breaker, where as this will avoid the fire and also electrical hazard that can be made from bad estimation. So be always make sure that you use IEC guidelines while calculating your cable size. So thank you for being with me. Let me